Hello guys, welcome back to our series about higher order differential equation, and today we are going to continue with solving more questions about homogeneous differential equations. And the previous videos I have explained the concept of homogeneous differential equations. So now we will be continuing, and in this question here we've been given the homogeneous equation to solve, and we have been given the initial conditions whereby we'll have to find the particular solution. So first of all, we have to find the general solution using the homogeneous equation given. So you first find the auxiliary equation, which was previously taught on previous videos. I will attach the links here and you can go and look for those who are new. So this will be m squared plus 4m plus 4 equal to 0. That is m squared plus 2m plus 2m plus 4 is equal to 0. That is, the roots are minus 2 and minus 2. And this will fall upon a case 2, whereby roots are real and repeated. So when roots are real and repeated from case 2, the solution becomes c1 plus c2x e power mx. This is the general solution. So our answer will be y is equal to c1 plus c2 x e power m is minus 2x, and this will be our general solution. So let's call it equation star. So now we have been given the initial conditions and we need to find the particulate solution from the only initial conditions. So we have the first initial condition as y of 0 is equal to 2. That is, when x is equal to 0, y is equal to 2. So from this equation here, when y is equal to when y is equal to 2, that means when x is equal to 0, y is equal to 2. So you replace the values. So c1 plus c2x, that is 0 e power 0. That means c1 is equal to 2. Call this equation 1. Then we have another condition is y prime of 0 is equal to 1. That means when x is equal to 0, the y prime is equal to 1. So first we have to find y prime by differentiating this equation, this y, with respect to x. So we say differentiate the star equation with respect to x. So y prime is equal to c1 plus c2x minus 2 e power minus 2x plus e minus 2x times c2. So replacing the values of the initial conditions here, that means y prime is equal to 1 when x is equal to 0 is equal to c1 plus 0 minus 2 e power 0 plus e power 0 c2. You can say 1 is equal to minus 2 c1 plus c2. So minus 2 c1 plus c2 is equal to 1. This is the equation 2. So we have the value of c1 already. c2 is equal to 1 plus 2 C1. So is equal to 1 plus 2 times 2, which is equal to 5. So value of C2 is 5 and value of C1 is 2. So the particular solution will be y is equal to C1 is 2 plus 5x e to the power minus 2x, and this will be our particulate solution. Hope you understand. So now going on to the next question. Next example, it says solve y double prime plus 9y is equal to 0. Again, we have to find the auxiliary equation of this. Will be m square plus 9m is equal to 0. M square is equal to minus 9. Nope, there is no m here. So m is equal to positive or negative 3i. This is a complex function where alpha is equal to 0 and beta is equal to 3. And this will be case 3, whereby roots are complex conjugates. So, and when case 3, the general solution is e power alpha x c1 cos beta x plus c2 sin beta x. So will be e power 0x c1 cos 3x plus c2 times 3x. Here we obtain that c1 cos 3x plus c2 sin 3x, and this will be our answer to the question. Okay, now moving on to the next example. Example says solve y double prime plus 25y is equal to 0. Again, auxiliary equation will be m square plus 25 is equal to 0. M square is equal to minus 5. So m root will be 5 plus positive or minus 5i, which it is a complex function, making it a case 3 scenario. So the formula will be e raised to, from here this is the form of alpha plus minus beta I, where alpha is 0 and beta is 5. So e power 0x c1 cos 5x plus c2 sin 5x. Answer will be c1 cos 5x plus c2 sin 5x. Again, another is an easy question about case 3. So we'll move on to another question again. Another question. Solve y double prime plus 7y prime plus 10y is equal to 0. Again, auxiliary equation will be m square plus 7m plus 10 equal to 0. That is m square plus 2m plus 5m plus 10 is equal to 0. Say roots will be minus 2 and minus 5. Roots are real and distinct. This falls to case 1 scenario, and during case 1 the solution was c1 e raised to m1x plus c2 e raised to m2x. So from here the solution will be y is equal to c1 e raised to minus 2x plus c2 e raised to minus 5x. Again, moving on to the next example, that is solve y double prime plus 8y prime plus 16y equal to 0. Again, finding the auxiliary equation, m square plus 8m plus 16 is equal to 0. That is m square plus 4m plus 4m plus 16 is equal to 0. The roots are minus 4 and minus 4. Roots are real and repeated. This is a case 2 scenario. By now you can be now knowing what the equation will be. General solution will be y is equal to c1 plus c2 x e to the power minus 4x. Doing more questions and more questions will make you more familiar to these concepts. So we'll go to another question, another example again. That is solve y double prime plus 100y is equal to 0. Finding auxiliary equation is equal to m square plus 100 is equal to 0. M square is equal to minus 100. So root will be positive or negative 10i, which will be the same as 0 plus or minus 10i, which is in the form of alpha positive or negative beta I, a complex function. That is a case 3 scenario where alpha is equal to 0 and beta is equal to 10. So we now know the solution will be e power 0x c1 cos 10x plus c2 sin 10x. Y is equal to c1 cos 10x c2 sin 10x. Another question. Again, we're going to do the next question, the next example. That is solve y double prime plus y prime plus y equal to 0. Again, this question gives us an initial condition, that is y of 0 is equal to 1 and y prime of 0 is equal to 3. Again, we have to solve the homogeneous function, then later we'll use general solution to get the particular solution using the initial conditions only. So same steps, auxiliary equation, m square plus m plus 1 is equal to 0. That is, m is equal to minus b, positive or negative, b square minus 4ac upon 2a, quadratic formula, is equal to minus 1, positive or negative. 1 minus 4 is minus 3, divide by 2. So the root will be minus 1 by 2 I. So this root is a complex function, so it is a case 3, and alpha will be minus 1 by 2 and beta will be root 3 by 2, and the general solution will be e power 1 by 2 x c1 cos root 3 by 2 x plus c2 sine root 3 by 2 x. This, let's call it star equation, which is the general solution. So now we need the initial condition, which was y of 0 is equal to 1, meaning that when x is equal to 0, y is equal to 1. So giving the initial condition to this equation, that is 1 is equal to e power 0 and c1 cos 0 plus c2 sine 0. So 1 is equal to c1. Then we have another initial condition, that is y prime of 0 is equal to 3. That is, when x is equal to 0, y prime is equal to 3. So now we have to find y prime by differentiating the star equation with respect to x. Differentiate star equation with respect to x, and it will be c1 cos root 3 by 2 x plus c2 sine root 3 by 2 x into minus 1 by 2 e raised to 1 by 2x plus e minus 1 by 2 x into minus 3 by 2 c1 sin root 3 by 2 plus root 3 by 2 c2 cos root 3 by 2 x, and here is an x. So when this is 3, when x is equal to 0, this is 3. So 3 is equal to e power 0 root 3 by 2 c2 minus 1 by 2 e power 0 c1. So 3 equal to minus c1 by 2 plus root 3 by 2 c2. So c2 root 3 by 2 c2 equal to 3 plus 1 by 2. c2 equal to 7 by root 3. So now we have the value of c1 and c2. We replace them to the general solution to get the particular solution. So our equation will be y equal to e power 1 by 2 x. c1 is 1, so it will be cos root 3 by 2x plus 7 divided by root 3 sine root 3 by 2x, and this will be a particular solution. Again, we will go on to the next question. That is, solve y double dash y triple dash plus y is equal to 0. Auxiliary equation is equal to m cubed plus 1 is equal to 0. That is, by expanding this is m plus 1 m square minus m plus 1 is equal to 0. So we can say m plus 1 is equal to 0, or m square minus m plus 1 is equal to 0. So m is equal to minus 1, or by this quadratic equation we get 1 by 2 positive or negative root 3 by 2 I. So here we are getting one root as a real and distinct and another root as a complex function. So what will be the equation? Will be y is equal to, for the real root it will be c1 e raised to minus x, plus, then for the complex function will be c1 cos beta x is 3 by 2 x plus c2 sine 3 root 3 by 2 x multiplied by e raised to 1 over 2 x, and this will be our solution. I think the next question will be the last question for today's video. So the question says, solve y triple prime minus y double prime plus 100y prime minus 100y is equal to 0. So the auxiliary equation will be m cubic minus m square plus 100m minus 100 is equal to 0. That is, m square m minus 1 plus 100 a minus 1 is equal to 0. That is, m square plus 100 is equal to 0, or a minus 1 is equal to 0. Again, we are getting two roots, positive or negative 10i or m is equal to 1. This is the same case as the last question, where we have a complex function and a real root. So the question will be c1 e raised to x plus c2 cos 10x plus 3 sine 10x. Yeah, this will be the question. So guys, thank you for watching. I will upload more questions to this, then we will go to the next subtopic of non-homogeneous differential equation. So let me know in the comments, should I do more questions or we can continue with the next subtopic. Thank you and goodbye.